Hey everyone, how are you doing? Thank you for the reply. It's always the worst when someone when you say something, you're asking a question, everyone's just dead silent in the room. So I appreciate it. There's still energy at this time in the day. All right, I guess people are still coming in, but I think we can get started. Are we already streaming, recording? Recording, excellent. All right. Well, hi friends. My name is Chris, and I'm a product manager in Firebase and the lead for Firebase Genkit. I've been working on open source projects for most of my career, first at Microsoft, now at Google, and I'm very grateful for the opportunity to be a speaker at All Things Open and to have the privilege of addressing you all today. To be honest, this is my first time presenting live on a stage since my last high school talent show. So it's a bit different than remote presentations, so please bear with me if I'm a bit of a rookie. I remember I came in here just a little bit earlier today. I got here really early because I was really nervous and I wanted to see what it was like to present. And that was before they put up the dividers here. And I thought I was going to be presenting to like 3 times this surface area for my first ever live presentation on like the keynote stage. And I was like, oh boy. What did I sign up for? I'm just gonna like freeze on stage. But they put up the dividers. Thank goodness. And yeah. Anywho, in this session, I'll introduce you to Firebase Genkit, a framework that you can use to start integrating generative AI into your applications today. But before I dive into the details of Genkit, you should know a little bit about Firebase if you don't already. I imagine a lot of you who came here, if you saw Firebase on the session were interested, probably know about Firebase. Can I get a show of hands for who knows at least a little bit about Firebase? Okay, vast majority of the room. That's awesome. It's going to be a pretty quick dive through just for the folks who are a little bit less familiar, and it's a nice segue into the rest of my presentation. So what is Firebase anyway? In short, Firebase is Google's app development platform. Our mission is to help developers succeed and create experiences that ultimately delight their users. We want to help ease the challenges of development so that you can focus on building incredible apps that do unique and interesting things. Firebase isn't just a single product, but a comprehensive platform with a portfolio of products, including serverless compute, storage, databases, authentication, hosting, analytics, and several other services to help you build and run your apps faster and better. And when I say apps, I mean Android apps, iOS, web, and even games. Firebase provides SDKs that support a variety of languages and platforms to best meet your needs for whatever and wherever you're building. For years, Firebase services have helped developers at every stage of the app development lifecycle, supporting some of the most popular apps in the world. And then AI changed everything. Well, not quite everything. For now, developers still need to build apps. We still need services to help us build apps and reach our users and make delightful user experiences. We'll see where we're at in 10 years, but for now, that's still the case. But we did see the emergence of new types of exciting use cases that were before impossible before the rise of generative AI. And growing demand from developers for tools and services to enable and accelerate the development of AI-powered apps and features so that they can differentiate themselves. That's why at Google I/O this year, if any of you attended or were watching, Firebase announced that it was expanding its mission to help developers build and run modern AI-powered experiences that users love. Fulfilling that mission starts with understanding the challenges that developers face when integrating generative AI into their apps. We spoke to a lot of developers who were trying to build all kinds of creative use cases with generative AI. And we found that we were hearing a lot of the same things over and over again. We heard that they were overwhelmed with the number of new concepts and tools they felt they needed to know to get started or to get to production. That prompt engineering was a completely kind of arcane, mystic art that was really time-consuming and really hard to get right. That the non-deterministic nature of generative AI required completely new approaches to testing and debugging their code. We saw that observability and production monitoring were becoming more important than ever before because We need to make sure that users are getting responses that align with their expectations, with the company's expectations, and that are accurate and safe. There's always a bit of risk with using generative AI in production in that regard. Developers said that they wanted to use languages that they were the most familiar with and that aligned with their existing tech stack at their companies. That isn't always just in Python, even though that is right now the dominant language for working with AI. We also heard about prompt management, agent orchestration, and many other problems that are very unique and specific to generative AI. And all of that research motivated us to build Firebase Genkit. Genkit is an open source framework to help you build, test, and productionize AI-powered applications and features. Genkit is a backend framework and currently supports the Node.js and Go runtimes. The Node.js SDK is currently in beta. This is still a pretty young product. We only announced it at Google I/O, so I think that's 6 months, 5 months old at this point. But we're rapidly approaching our first stable release and hope to get there by the end of the year, so definitely stay tuned. The Go SDK is currently still in alpha. We are rapidly iterating on it based on customer feedback, but if you really want to be able to build generative AI features in Go, and I'm assuming many folks here are passionate about open source and contributing and giving feedback, please give it a try and let us know what you think. So, more concretely, what is Genkit? I think of it as 3 main parts. First are the open source SDKs for Node.js and Go that I alluded to earlier. They provide the core primitives for critical AI components like generative AI models, embedders, vector stores, tools, agents, and other basic building blocks of AI-powered applications. They are designed to be lightweight and low level, so developers have full control over their AI application architecture. They are idiomatic to the language that they're in, so that JavaScript and Go developers can learn them quickly and be productive immediately. And finally, they're built to be platform and provider agnostic. So you can use Genkit technically without using any other Firebase services. You can use Genkit without using Google Cloud technically. You can deploy it anywhere that supports Node.js and Go runtimes. It's just a lightweight library. And it's also made to work with a variety of AI models, vector stores, and other AI service providers. None of these are actually, no specific model or specific provider is built into the core SDKs. And that brings me to the next part, Genkit's plugin model. Plugins are used to integrate Genkit with various services like particular AI models or vector stores and are a core part of Genkit's extensibility model. There are official plugins maintained by Google, like the Google AI plugin that gives you access to the Gemini family of models through AI Studio. And there's also several built by the community, like an OpenAI plugin and a Qdrint plugin for vector store. Genkit has an open plugin ecosystem, so anyone can build and publish one as a package to NPM or to Go. Or build your own private plugins for custom integrations for within your own company if you have, let's say, an in-house model, for example. Then there are the developer tools. Genkit has a dedicated CLI and local developer UI that let you rapidly test your AI flows/functions and prompts, debug your AI application code, and evaluate outcomes with multiple test cases. Now, let's dig into the details so you can get a better idea of what it's like to use Genkit and what it can do for you. I imagine a lot of you in this room are developers and you want to see code. That's what's going to make the most sense to you. So, despite all the things that you can do with Genkit, getting started is super simple and easy. You just install the relevant packages. In this case, all of these code samples are going to be for JavaScript, by the way. Partly because it's the most mature, partly because I actually don't know Go that well, to be honest. So you install the relevant packages, in this case, the Genkit.js package and the Google AI plugin. You set the model key in an environment variable, please don't leak that, and copy and paste a code snippet just like this to make your first generation with just a few lines of code. In this code snippet, we're, of course, importing the core packages. That's the Genkit package and the Google AI plugin. We're in the AI equals Genkit line configuring Genkit. In this simple example, that just means registering the Google AI plugin by putting it in the plugin array, and then calling Gemini 1.5 Flash, one of Google's latest and greatest models, asking it, how are you? I imagine very few people ever ask the models how they are. And from here, we'll explore how Genkit scales to more complex scenarios. So what if you want to try out multiple models, even from different providers, and compare them? Or maybe migrate from one model provider to another entirely? Well, fortunately, Genkit makes that really easy with its unified generation API. You can use a consistent interface to interact with any model configured from a plugin. In the code, you can see that we're importing and configuring plugins for Google AI, OpenAI, Anthropic, and registering all the models they contain with Genkit in the plugins array. From there, we're switching out a model is as simple as changing the model name in the generate method. That's it. The unified generation API also supports multimodal input and output, so it can also be used with image generation models like Imagine or DALL-E, but in this case, we're giving it an image to compose a poem about. So a very flexible, simple to use, and powerful AI for doing one-off generations. The generation API also supports generating structured data that conforms to a specified schema. This is really helpful when you need to generate data for an input to another function or a UI element that expects a specific input type and shape. For example, if you were trying to populate the UI for a character profile in a fantasy video game, you might use an output schema like the one I have in the code sample here, where we're trying to generate a character that has a name, a role that's either a knight, mage, or archer, and an interesting backstory. In JavaScript, Genkit supports the use of Zod, a very popular schema declaration and validation library for defining the output schema. It's a lot more compact and readable than straight JSON schema and a lot easier to work with, and can also be used for type validation in the code. So it's nice, multi-purpose, compact, and convenient. One of the powerful features Genkit provides is that if your model doesn't natively support structured output, most of the latest hosted foundation models from like OpenAI and Google and Anthropic do. But if you don't, let's say maybe you're using a local model or something like that, Genkit will inject a prompt instructing the model to generate in the defined schema and automatically validate the output. In this way, it can let models kind of emulate structured output capabilities. Genkit's define tool method lets you create functions that the AI model can choose to call if it thinks the tool is needed. For example, if you ask an LLM what the weather is predicted to be tomorrow, normally it wouldn't have an answer, or it would just make something up because the weather prediction for tomorrow wasn't included in the model training data. However, if you give it access to a weather tool and you provide the relevant schema and descriptions that tells it how to call the tool and how to interpret the response, then it can actually call that, get the information, display it, pass it back to the model to generate an output that actually provides you a real answer. In the code sample, excuse me, you can see how we're again using Zod to define the input and output schema that is given to the AI model so it knows how to call the tool and interpret the output. You can give a model multiple tools that it can choose to use or not use in order to respond to a given query. By wrapping your internal APIs in a defined tool, you can give the AI model access to your internal systems and potentially even give it write access, which might be necessary for a customer service agent, for example, that needs to reschedule a flight or needs to access customer-specific data or issue a refund. Now, we discussed how you might use tool calling to give the LLM access to data that it wasn't originally trained on, like the weather or inventory availability. However, you would use vector search if you wanted to find passages from a text or items in a database that are semantically similar in meaning to a given query. Here's a diagram that might give you an idea of what the architecture of a pretty simple RAG system looks like, or what we would call naive RAG. If I didn't say it before, by the way, RAG is Retrieval-Augmented Generation. All it means is that you're taking some context from a data source, passing it to the model for it to be able to inform its responses. A classic example of a RAG system is one that answers questions about a PDF it wasn't trained on. In the diagram, the PDF would be the knowledge base up at the top there. And you can use the embedding model and a vector store to create mathematical representations of each passage in the PDF and store them. These mathematical representations are called embeddings, and they capture the semantic meaning of the text in numbers. Then when a user asks a question, the system does the following. It calculates an embedding for the user's question, so the input question or query. This translates the question into the same kind of mathematical representation as the stored passages. You definitely want to use the same embedding model so that it matches up. 2, it compares the question embedding to the passage embedding in the vector store. So it's trying to gauge the similarity of the two vectors or the two representations of the question and the passages that you had indexed. This is done using a similarity metric like cosine similarity to find the passages that are closest in meaning to the question. Then it retrieves the most similar passages. These passages are likely to contain the information needed to answer the question. And it provides the retrieved passages to the LLM as context. The LLM can then use this information to generate an accurate and relevant answer. This approach allows the LLM to access and understand information from the PDF even though it wasn't explicitly trained on it. In the code snippet I provided, you can see how the retrieval part looks with the Pinecone plugin, a very popular vector store provider. We have the Pinecone plugin configured with an index and embedder. In this case, the index is named Bob Facts, and we're using the text embedding Gecko embedder, which I think is actually a little outdated. I should update that. The retrieval step then finds the relevant documents or passages relating to our query, asking how old Bob is. I think we're storing Bob Facts in this example, and then passes that to the LLM as context so it can answer the question. So what it'll do is it'll take my input query, how old is Bob? And among the list of Bob facts that have been indexed, it might say that that is semantically similar, because it uses, let's say, the word old, to any passage that might include the word years or years old, for example. Typically, production RAG workflows are quite a bit more complex than this. There's a reason that we call it naive RAG, and you can do a lot more advanced things like re-ranking steps or query rewriting so that it might match up closer to the text in the passage. And Genkit scales to those needs as well and allows you to wrap retrievers in more complex logic so that you can build these powerful workflows. Now, what if your AI feature requires more than just a single generation step? This is automatically true if you're using something like the RAG sample from the last slide, since your workflow will include at least one retrieval and one generation. However, there's also a number of reasons why you might want to break up a task into separate generation steps. For example, if you're trying to generate a big complex schema. I've had some developers that we worked with that were using Genkit that were trying to output schemas that were like 20 parameters long, right? Fairly complex and a fairly difficult task for most LLMs. In those cases, it's oftentimes useful to break up that generation task into multiple separate generations. So maybe you generate half of those fields with one generation call and half with the other, and then you can combine them programmatically. In this sample that I provided, it's even simpler. I'm just breaking up the task of generating a kid's bedtime story into multiple steps. So each subtask is simpler, and the model has an opportunity to evaluate the quality of the ideas generated in the first step before proceeding to the next one, as opposed to doing it all in one go. This type of strategy can sometimes lead to higher quality inputs, partly because of the reflective capability of having it in multiple steps, and also because it's just a simpler, narrower task for the LLM to be able to do. Now, how would you normally try to group these steps that are logically connected so that you can invoke them all at once? Well, I think the answer is probably pretty obvious to most folks. You just wrap the logically connected steps in a JavaScript function, right? Good instinct. But without a little bit of extra work, that function won't logically group the traces or the telemetry for those steps, making end-to-end observability and monitoring, as well as debugging, a little bit more difficult. And that's where flows come in. Genkit flows are just special observable functions. You literally use them just like you would normal functions. You use them to group related code like you would with a regular JavaScript function, but they are integrated with Genkit tooling and observability. You can invoke flows from the CLI. You can see the little CLI command using the Genkit CLI at the bottom below the code snippet in order to quickly test them, try different inputs. And they will automatically, when I said they're also integrated with Genkit telemetry and tracing, if you wrap logic in a flow, it will also automatically provide a parent trace for the logic contained within. More complex features might have multiple subflows as well to help you better organize your code. Another pattern that we have observed from developers is that they want a lot of flexibility with the way that they manage, version, and store prompts. In some organizations, a subject matter expert might be the primary person working on and tweaking the prompts as opposed to the application developers. You might even want to host your prompt file at a URL so you can change it on the fly without modifying your core code. This is where .prompt files can come in handy. They encapsulate rich prompt templating using handlebars format with model metadata and input-output schemas so that you have control over every aspect of the generation within a single convenient file. They are designed to be easy to write and easy to read to facilitate a nice user experience for both developers and non-developer prompt owners. The prompt file can then be executed from your code on its own or within a flow as part of a larger system. And just like the capabilities that we mentioned about the Generate API earlier, the ability to do structured output, the ability to do multimodal input and output, .prompt files have all of the same capabilities, all encapsulated in one nice convenient place. You might also notice that it uses what we call Pico schema, which is something a developer on our team invented to make that is much nicer to write, to do schema specifications than straight JSON schema, which is pretty verbose. Now, this is something that isn't technically fully released yet. It's only available in a preview package, but will officially be supported in our upcoming 0.9 release of Genkit.js. Since you all came over here, I thought I'd give you a little sneak peek. It's more ergonomic for multi-turn use cases than using the Generate API I showed earlier, and removes the need for developers to manually maintain conversation history. So if you're trying to build a chatbot and you still want all of the capabilities of the Generate API, including things like structured output, multimodal capabilities, our chat API is the way to go. I also opted to keep this code sample very simple, so it would fit on the slide. But you will be able to specify a state store like Firestore through Genkit plugins to durably log conversation history and maintain state for future reference. For more complex multi-agent use cases, you can also have multiple chat threads going at once. All right, now I know that was a lot of code. I appreciate everyone bearing with me. I hope it was interesting. Genkit was designed to empower developers to build anything that generative AI is capable of, while providing a fundamentally approachable and ergonomic developer experience. I know we covered a bunch of concepts that might be new to you if you're not very familiar with generative AI. But remember, these are all just tools that we provide for you to use at your disposal, to use when you need them. You can start simple and make your first generation request in just a few quick steps. Getting started with generative AI doesn't have to be that complicated. And then you can just scale up, explore, and experiment from there. Now, I want to get to a topic that I think is one of Genkit's greatest differentiators, and one of my personal favorite parts of the Genkit AI development experience, our developer tools, and specifically the developer UI. This is what Genkit's developer UI looks like. You can launch it from the terminal using the Genkit CLI, and it will open a local web app in your browser that looks just like this. You can run your code so it can discover everything that was registered in your Genkit instance. If you remember the AI equals Genkit line of code that I had in all of my samples, that is the Genkit configuration, and that's where you register all of the plugins. When you open the developer UI and you run your code, the components in the developer UI are directly connected to your code and will reflect it. Registered components that are picked up by the developer UI include the plugins that you configured in the Genkit configuration line, as well as any define X components like define flow and define tool methods I showed you earlier. Those all become available in the left-hand column on the developer UI. For example, in the image shown, you can see that I'm interacting with Gemini 1.5 Flash in the model runner/playground, which is a model registered through the Vertex AI plugin. You can also see other models brought in through the Vertex and Google AI plugins in the left-hand column. The model runner is a really convenient way to quickly explore and compare different models and test prompts. Of course, Google provides the hosted Google AI and Vertex AI studios to let you explore Google models. But Genkit's developer UI lets you do that with any provider that you have set up through a plugin, all in a single interface, including locally running models. So in my earlier code sample, I had OpenAI, Anthropic, Vertex AI, and Google AI all enabled. I would be able to directly compare and play with the different models side by side, all in this single locally running environment. It also supports multimodal input. As you can see here, I'm asking it, who is that cute little character over there? And it told me that is Sparky, Firebase's mascot. It also supports multimodal and multi-turn conversations. So remember the concept of flows I introduced earlier when I described them as functions that are integrated with the Genkit tooling and observability? Well, this is what I meant. I showed you that you can invoke flows directly from the Genkit CLI for really quick testing, but having to put in like a pretty complex object in the CLI is not quite as fun and ergonomic, right? It's really nice and quick for easy inputs like a string, but as you get more complex, it's nice to have a UI that pre-templates things for you. All flows defined in your code are discovered by the developer UI for quick and easy testing with various inputs. If you have an input schema defined for your flow, it will start you off with an input template, so you don't need to format the whole input object from scratch. In this case, my input was still pretty simple. It was just an object with a question string input. This is really convenient, but it's actually not even really the coolest part. If you select the View Trace button at the bottom corner, you can inspect the traces for every step of the executed flow to help you debug any issues and verify the outputs of intermediate steps. It even renders images, like the image of the menu I was feeding to the model for this particular flow, where I was asking questions about things that are available on the menu. In the top right corner, you'll also see a couple additional valuable options. You can replay particular steps to alter the inputs or prompts and see what impact on the outcome it has by opening that step in the input, with the input pre-populated in the component runner. So in this case, I'm looking at a step where it ran the model and passed in the image and some input text to the model. If I didn't like the output, or if I wanted to see how the output of that step would change if I slightly tweaked the input prompt, I could click that button, open it in the model runner, which is the page that I showed you just in the previous slide. And I would be able to experiment with it. I'd be able to alter the prompt, I'd be able to change the image, and then kind of see what would have happened. So this is a very powerful debugging tool. And it works with more than just the model runner. It also works with retrievers. So if you have a retrieval step in your workflow, you can go back and try to optimize the query, or try to see what types of queries work and what don't. You can also export the traces to share with your team. Remember, this isn't a hosted service. It looks somewhat similar if you're familiar with Langtrace or some of the other observability tools, but this is all working within your local environment. Even if you used a local model through Ollama, for example, and you were completely offline on the plane trying to prototype some AI features, all of these capabilities would still work exactly the same way. This is all intended to significantly speed up your inner dev loop and try to get you from 0 to 1 as fast as possible. Finally, Genkit tooling allows you to easily run evaluations with a data set of input on your flows. You can configure evaluation metrics through plugins or create your own. This makes rigorous testing for your flows significantly easier and lets you assess the quality of ultimate outcomes from multi-step processes, not just a single model response. The developer UI provides a nice UX for evaluation results and rationale, as you can see here. On the right-hand column, you can see all the scores. And if any results seem kind of poor or suspect to you, you can view the trace for each response to go through the debugging workflow that I discussed in the last slide and still be able to tweak every prompt, see what went wrong and what can you do to improve it. All right, so now we've learned a lot about Genkit's code and tooling capabilities. These will help accelerate the development of your AI-powered application by providing ergonomic APIs and awesome tooling to help you quickly test and debug your code. But how can Genkit help you once you've made your first deployment? Maybe you're actively testing your new AI feature with a subset of your customers, or maybe you're already fully in production, but you want to make sure that things are working the way that you expect them to. This is where production monitoring becomes critical to make sure that your AI feature is behaving as you expect it to with regard to cost, latency, behavior, and safety. Fortunately, Genkit is thoroughly instrumented with OpenTelemetry and custom metadata. Much of the mechanics that enable powerful observability experiences in the developer UI also allow for seamless integration with production monitoring services. Our official provider, or the one that we have an official plugin for, is Google Cloud's Operations Suite, which you can set up with Genkit through the Google Cloud Telemetry plugin, even if you're not a Firebase user. This gives you an extremely powerful and robust system for viewing relevant performance metrics and traces from your AI application with minimal additional work or setup. Of course, this is a core Google Cloud developer experience, so you can expect reliability and high scalability. If you're a Firebase developer and you love using the Firebase console, I have even better news for you. Firebase AI Monitoring provides aggregated views of traces and metrics on top of the Google Cloud Operations Suite in a sleek and simple UI that is purpose-built for AI use cases. It lets you quickly view critical information like flow or feature success rates in production, token usage, latency, and more. It is currently in private preview with a waitlist, but has plans to expand access in the coming months, so definitely stay tuned. If you liked the developer UI trace view to help you step through your AI flows and debug your locally running application, then you'll love the same developer experience is available in the Firebase AI monitoring UI for your production workloads. Except it's viewable by everyone on your team that has access to your project. So you don't need to go around just sharing the JSON traces from the developer UI, while that is handy in a pinch. And now let's talk a little bit more about the breadth of Genkit's plugin ecosystem and what models and vector stores and other integrations that we support. So we support a variety of different models. This slide has the official plugins listed, so that is Vertex and Google AI for access to the Gemini family of models, as well as other big models like Imagine for image generation. We also provide access to the Vertex Model Garden. So if you want to use Llama 3.2, which was recently announced, or Anthropic through Model Garden, and have all of your billing consolidated through Google Cloud, you can do that with the Vertex Model Garden plugin. You can also use Ollama to be able to experiment locally on your own device or self-host a model, particularly open source models like Llama and Gemma. And there are also a number of community plugins. I showed a few of them in the code snippets earlier, such as OpenAI Anthropic. But there's actually, I think, 25 or so community plugins, and many of them are for models. So there's also access to Cohere and to GitHub models and various other popular providers. So no matter what providers you want to build with, what models you're interested in trying, Genkit's open plugin ecosystem has you covered. And if you don't see the particular model you're interested in using available in the existing plugins, anyone can build one. I encourage you to contribute. As far as vector stores go, we have official support through plugins for Cloud Firestore, Vertex Vector Search, PG Vector on Cloud SQL, and Pinecone. And we also have community plugins for Qdrant, AstraDB, and multiple others. The plugin model is also extensible beyond AI components like models and vector stores. It can also be used to give you integrations with platform features. The plugin model is really extensible, and we left it open to see how developers would use it to try to extend Genkit. It was purposefully built so that developers could tweak it in a variety of different ways. The Firebase integrations give you access to critical features like Cloud Functions for Firebase and make it easier to deploy your AI workloads to Firebase. The amazing magic of using Cloud Functions for Firebase when you're working with Genkit is that it also provides you callable, what we call callable functions through client SDKs that support iOS, Android, web, Flutter, and a variety of other platforms that are escaping my mind right now. It also gives you access to integration with Firebase App Check so that you can securely call your backend flows from your client through app attestation. Integration with Firebase authentication if you want to make sure that only particular users have access to parts of your flow, or particular users have access to their own data that might be available through RAG workflows, for example, or only have privilege to use particular tools, as well as Firebase AI monitoring that I covered in a little bit more detail in the previous slides. So the magic of Genkit plus Firebase gives you a really powerful experience for trying to integrate generative AI into your applications and make them callable from your application client in a secure, ergonomic way. And like I mentioned earlier, because Genkit is just a lightweight library that comes with a variety of different plugins, if you want to integrate it into various systems, you can deploy Genkit anywhere that supports Node.js and Go runtimes. So you can deploy to Firebase, of course, through Cloud Functions for Firebase. You can also deploy through app hosting. If you use Next.js or Angular SSR features, you can have Genkit directly used in the API routes. You can deploy to Cloud Run or GKE or any other container provider. We've had a number of users deploy to Vercel, for example. And Genkit, and I think this is really important to highlight among this audience for the purposes of open source and community. Genkit is fundamentally built to be extremely extensible. We have detailed documentation for writing plugins, for building custom integrations, not just for AI models and vector stores, but also for authentication providers, telemetry providers, and any other platform that you want to integrate it with. It is open source on GitHub with an Apache 2.0 license. Of course, you're free to file issues, to participate in discussions, to contribute code. We've had a number of folks as part of our community already make contributions to the core framework for things that they wanted to enhance or improve. All right, that was a lot of content. Even the recap looks kind of intimidating, if I'm being honest. We covered how easy it is to get started with Genkit, a variety of the key features that make it easier for you to build anything from simple to complex AI-powered features, including the Unified Generation API that lets you use any model supported through our plugins, how to produce structured outputs and type safety for easier integration into your application, tools and function calling to let the model access the outside world and call your own APIs, vector search to give it context it needs to give you accurate and relevant responses, observable flows so that you can have both local and production observability for multi-step complex workflows, prompt management to enable different ways of working with and iterating on prompts, ergonomic APIs for building simple chatbots, tools to help you iterate on your application rapidly, and much more. So to get some of the ideas flowing, what can you build with Genkit? What can you use all of the tools that we just covered to do? A few common use cases that we've seen from our existing community are autonomous agents and chatbots that can execute actions like customer service agents, for example, that can issue refunds or answer questions about a particular service. Structuring unstructured content. So this might be taking a variety of reviews and putting this into a format that is more, that might include like a average sentiment rating, for example, as well as like an overall summary of the review. Or taking lots of data and trying to uncover insights from it. Multimedia analysis and generation. We've seen many of our users try to build creative generation tools like story generators or image generators, image editors, for example, as well as intelligent decision support. You can use Genkit and other AI models to be able to uncover insights and help you make decisions faster in your organization or help users make the right decisions. So the next step is just to get started with Genkit. You can go to our GitHub, see the getting started instructions. It'll also link you to all of the relevant documentation. I encourage you to try both Node.js and Go, whatever suits your fancy. And you also find at our GitHub a link to our Discord channel, which is very active. We try to do our best as a team to build out in the open with our community. So we're constantly soliciting feedback. We post a lot of our designs before they officially go into the framework, into the chat to get some feedback. And we have some very engaged community members that love to make sure that we're heading in the right direction. You can also start a discussion on GitHub if you'd prefer, or file an issue if you run into anything. And that's it. With love from the Firebase team, thank you so much for coming to my presentation. This was my first presentation ever, so please leave a review if you liked it. If you hated it, don't. Subscribe to the channel. There is actually a Firebase channel, by the way. You can subscribe to it. And thank you so much for being an incredible first-time live presentation audience. I can't say how much I appreciate it. Also for laughing at some of my lame jokes. I really appreciate that too. Thank you.